Dear students, in this video I am giving some example of IUPAC nomenclature. I hope by doing this IUPAC nomenclature will be more easier to you. Okay, and I at the first of the video I just said to information that in case of 2 or 3 more substituent we use di for 2 and tri for 3. Okay, and another information that is between two number we use comma, and in between number and word we use hyphen. Okay, now C2H6 CH3 CH3, you can see that this is an alkane, and you all know in case of alkene N is used for suffix, and as the number of carbon atom is 2, so eth. Okay, so this is ethane. Okay, and in this case there is a double bond, so it is an alkene, and in case of alkene we use in for as suffix, and 1 2 3 4 carbon number of carbon atom, so this is butene. Okay, the third case there is a branch in hydrocarbon, so in case of branching we must give number, we have to give number to the carbon atom of the longest carbon chain. Then we have to decide from which side we do the numbering. Okay, and we all know that substituent, the carbon atom which is substituted, we must give them lowest number. Okay, so I am doing the numbering from this side 1 2 3 and 4, and you must know that the number of carbon in the longest carbon chain which is substituted is written as the number of carbon atom, so 2, that is, and this is substituted methyl group, so 2 methyl, as the methyl group is at the 2 position, so 2 methyl, and as the longest carbon chain contain 4 number of carbon, so that is but, and as there is no double or triple bond, that is an alkane, so 2 methyl butane. Okay, and in this example we can see that there is a double bond, so this is an alkene and substituted alkene. At if you, we can see that in case of presenting double or triple bond and substituted also, then we must give the priority to the double or triple bond, so we do not do the numbering from this side, so numbering should be in this side 1 2 3 4 and 5, and we can see that there is 2 substituent at the 4 number of carbon, so 4 4 dimethyl, and I am saying that in between two number we must add comma, so 4 4 dimethyl, and longest carbon chain contain 5 carbon atom, so pent, and the double bond is in 2 position, so pent 2 in. Okay, next example, this is also an substituted alkene, and the substituent at 2 position, so 2 methyl, longest carbon chain contain 4 number of carbon for this but, and as the double bond in 2 position, so 2 in, so 2 methyl but 2 in. Okay, next example, COOH present means this is an carboxylic acid, and you all know in case of carboxylic acid E must be replaced by oic acid, so and number of carbon atom is 3, so propan, and E replaced by oic acid, so this is propanoic acid. Okay, next CH3 CHO, by seeing this functional group CHO we can understand that this is an aldehyde, as this is aldehyde we all know the E is replaced by Al, so and number of carbon atom is 2 for this ethan, and E is replaced by Al, so this is ethanol. Okay, next, in the previous video I am said that this halogen atom, this halogen atom is going to the prefix, and we must put the number also, as 2 in chlorine group is in 2 position, so 2 chloro, and as the longest carbon chain contains 3 number of carbon, so propane, so this is 2 chloropropane. Okay, in this example we can see that there is a hydroxyl group, as this is an hydroxyl group, this is an alcohol, and you all know in case of alcohol E is replaced by all, so and we must put the number of hydroxyl, number of carbon at which the hydroxyl group is substituted, so and we just do the numbering from this side, so 1 2 3, and this is propan 1 all. Okay, this is also one alcohol, but this hydroxyl group is replaced here from 1 position to 2 position. Okay, so this is propan 2 all, and and we can see that in case of positional isomerism they both are alcohol and same number of carbon atom, same molecular formula, but their functional group position is different, so these two are positional isomers. Okay, now another type of question, write the structural formula of 2-methyl 2-butene. Okay, 2-methyl 2-butene, this from butene we can see that longest carbon chain contain 4 number of carbon, as there is a but, so first we draw the carbon skeleton, that is this 4. Okay, and we can see that 2-butene means double bond in 2 position, so that is carbon skeleton becomes this. Okay, now 2-methyl, so we can understand that at 2 position 1 methyl substituent is present, so 1 2 3 and 4, and 2 position 1 methyl group. Okay, so this is the carbon skeleton we form. Now it's our duty to fill the valency of carbon, so this is 1 valency is filled, so 3 CH3, this is complete, this is also complete, 1 hydrogen here in case of 3 hydrogen. Okay, so the structure becomes CH3 C CH3 double bond CH CH3. Okay, so this is 2-methyl 2-butene or butene. Okay, both are similar. Okay, I hope you just understand how from the name we can draw the structure also. Okay, next example, 2-bromo propane. So 2-bromo, we can get bromine atom at 2 position, and from propane we can understand that the main chain carbon skeleton contains 3 number of carbon, so that is this skeleton. Okay, as propane means all single bond is present, and 2-bromo means 1 2 3 in 2 position 1 bromine atom is present. Okay, now it's our duty to fulfill the valency of carbon by putting hydrogen, so this is CH3 and only 1 valency is left, and in case CH3, so the structure become CH3 CHBr and CH3. Okay, next example, you also do another type of example from your any type of book. Now ethanol. Okay, this all indicates this is there is a present type of hydroxyl group, and this is alcoholic family. Okay, so ethanol, one must be present OH, and from ethan we can understand that 2 carbon atom is present there, so carbon skeleton is CC, and 1 hydroxyl group is present there, so remaining carbon you must fulfill by valency of carbon is fulfilled by hydrogen, so CH3 2 is filled up, so H2 must be put, so the structure becomes CH3 CH2 OH. Okay, I hope you understand this. Next, different type of question, last type, write the structural isomer of C4H10 and C6H14. Okay, first I am just try to understand that this C4H10 is which type of hydrocarbon, means with which general formula it's similar to C4H10. Suppose we all know in case of alkane the general formula is CnH2n plus 2. Okay, now putting n equal to 4, we can see that H must be, putting n equal to 4, H must be 2 for 8 plus 2, that is C4H10. So this is an alkane. You must understand that this is an alkane. Now it's our duty to make the carbon skeleton, okay, by putting 4 carbon at the longest carbon chain. First C, single bond C, single bond C, single bond C, that is C. Now it's our duty to fulfill the valency. So CH3, here CH2, here CH2, here CH3. So one isomer, and this is, you all know, normal butane. This is butane. Okay, now we just make another isomer by putting 3 carbon atom in the longest carbon chain, that is 3 carbon atom is longest carbon chain. Now we put the substituent, 1 carbon atom as substituent at the 2 carbon atom. Now we just make the fulfill the valency of hydrogen atom. So we get this type of structure. Okay, and you just do the nomenclature 1, 2, 3. So this methyl group is at 2 position. So this is 2 methyl 1, 2, 3 for 3 carbon atom propane, 2 methyl propane. Okay, no other isomer can be drawn from the C4H10. Okay, and these two are similar in molecular formula, but their structure are different, so they are structural isomers of each other. Okay, now C4 C6H14, C6H14. Okay, putting N equal to 6, we can see that 2n plus 2, that is 12 plus 2 equal to 14. So this is similar to CnH2n plus 2, where n equal to 6. So this is also an alkane. First, in case of C6H14 also, we just make a carbon skeleton putting 6 carbon atom at the longest carbon chain, like this, C, 1, 2, 3, 4, 5, 6. Now we just fulfill the valency of carbon. Okay, like this, 4, 4, 4, 4, 4, 4. Okay, so H, and this is known as 6 carbon present there, that is hex, and as this is alkane, so this is hexane. Okay, next, in next isomer we just make chain of 5 carbon atom. Okay, and just attach one CH3 group at different position. Okay, first like this, 1, 2, 3, 4 and 5, and just attach CH3 group at different position. Like in this structure we attach CH3 here, and another structure we just put CH3 group here. Okay, now we just fulfill the valency, CH3, CH, CH2, CH2, here CH3, here also CH3, CH2, here only 1 hydrogen needed, here 2 hydrogen needed for fulfill of valency, here 3. Okay, so next both two isomers we get, and we must do the nomenclature also, 1, 2, 3, 4, 5. So 2 methyl, longest carbon chain contain 5 carbon, 2 methyl pentane. Okay, and in this case 1 2 3 4 and 5, so 3 methyl pentane. Okay, next, in the next type of isomer, we just do that, make chain of 4 carbon atom and attach 2 CH3 group at same position. Okay, and attach 2 CH3 group at same position like this, 1 2 3 and 4. Okay, and we make 2 CH3 group at same position, means this, like this. Okay, and we just fulfill the valency, 2 hydrogen needed, here 3 hydrogen needed. Okay, so in this isomer we already said that in case of 2 substituent we use di. Okay, so giving numbering 1 2 3 4, so this is named as 2,2 dimethyl butane, as longest carbon chain contain 4 number of atom. Another one isomer that can be drawn here, that we just make chain of 4 carbon atom and attach 2 CH3 group at different position. Okay, here and here, so 2 CH3 group at different position. Now we just, here 3 hydrogen needed for valency, here 1, here also 1, here 3, and we do the nomenclature 1 2 3 4. So 2 substituent are at 2 and 3 position, so 2, 3 dimethyl butane. Okay, so 1 2 3 4 5 isomer can be drawn. Okay, this is up to this video.